Hello, and welcome to the Argyle AI Decision Maker Summit, revolutionizing business strategy with AI. My name is Nick with Argyle, and it's great to have everyone joining us today. A couple of notes before I turn things over to our esteemed speaker. First, a quick reminder to stop by our sponsors' virtual booths at any time during today's event and for the following week. Our partners are committed to providing you with valuable content and a great overall experience. At any time during today's event, you can visit their virtual booths from the main agenda page, which include complimentary materials, information, and meet and greet opportunities. Throughout today's event, you will also have the chance to win one of several prizes. So be sure to check out the prizes and raffle rules tab of the interface to see how you can earn points. To ask questions throughout the session, simply type into the Q&A chat and we will address your questions at the end of the session. Now, without further delay, I would like to introduce our speaker, Vikram Gupta, Product Management Leader, Cohesity. We're super excited to have Vikram with us today for a thought leadership presentation titled Using Generative Artificial Intelligence, GenAI, to Unlock Knowledge, Learnings, and Insights from Your Enterprise Data. Welcome, Vikram. Over to you.
All right. Thank you, Nick. Hello and good morning, good afternoon, and good evening if you're dialing in from far away. So today, I think what I'm going to do is give you a quick um, rundown of how we are thinking at Cohesity about AI, how we can leverage AI and help our customers get better insights into the data. So what I want to do first is talk a little bit about AI in general and what it means to us, and when maybe you can take some pointers how you should think about AI and figure out what's the best technology or the best way to connect AI to your data. So I think at the beginning, right, we should all understand what AI is all about, right? So AI at the core is basically trying to simulate intelligence that humans have. Now, AI is far from doing that, and I personally believe that. And but it has made a lot of advancements where it can do certain type of things. So, for example, it can understand, it can learn, it can reason, it can decide, it can solve certain things. And we use a lot of technologies today on our phones, on our TVs, and our laptops that use a lot of these technologies. Netflix uses to recommend what movies you should watch. Amazon shows you what products you may like based on what you have purchased in the past, right? So it's all over the our daily lives today, from chatbots to facial recognitions and even in cars, right? So Tesla, BMW, all of these guys are using AI to help and assist and make our lives better. We also fundamentally believe, I think AI could be a great assistant rather than just taking over the whole world, right? So we are investing in AI as well to see how we can use our technology to help our customers get better insights on the data that we store on our platform. I think I also wanted to touch up a little bit about the types of AI and the capabilities it has, right? So that you can start seeing how we have kind of built certain solutions around it. At the highest level, right? So there are these four types of AI, and reactive AI, which is the most simplistic one, which is all about taking a stimulus and then acting on it, right? It could be you're ringing a doorbell, or you are asking a question on a chatbot. It's sophisticated, intelligent, but it has its own limitations. It doesn't have a lot of memory. It doesn't store and understands what's happened in the history long back. Limited memory AI is basically a system which starts to store some information about okay, what you have done in the past, and then based on that give you or solve the problems that you're asking it to solve. Theory of mind, self-aware, these are all, I would say, are reserved for Hollywood. So for example, I think the classic example we use is theory of mind AI would be like a Terminator, which is trying to be like humans, but it doesn't, and it can do a lot of things, but we don't have that today, right? And self-aware would be like Skynet, which is like even bigger system which is controlling all of these Terminators and things like that, right? I think we are like far away from any of those technologies. We are still building reactive machine learning and AI technologies versus and limited AI systems. So I think we are in good shape for now. Um, I think you've probably heard all of these terms as well in various settings. And The idea here is we use this AI to solve several problems. Computer vision specifically is all about images and videos and trying to understand what's going on between them. Speech recognition is all about understanding what the person is saying and understanding what's their intent behind it. Neural network, deep learning networks are basically ways by which AI becomes smart and tries to analyze and then predicts what it should do. And then finally, natural language processing is all about understanding the language humans speak, right? So if I'm speaking English, then just like how I speak to Siri or Alexa, it understands what my intent is, what my question is, and then tries to give me an answer back in the natural language processing, right? So again, all of these terms do a very specific thing in the AI world, and they are designed to help solve some problems. We are using deep learning, neural networks, and natural language processing, all three of them together, to uncover insights on the data that is stored on our platform. Um, and I think you probably have also heard some of these terms around what are different types of machine learning. So in the previous slide I showed various technologies, and then how machine learning executes or understands what it should learn is based on different techniques. Supervised learning is all about humans telling the machines what they should learn from. It's like teaching a kid multiplication table, right? You tell him what is 1 times 2, 2 times 3, 2 times 4, and then the machine learns that. Unsupervised learning is all about I'll give you some data, try to figure out what's in it, right? So it's the next level of evolution, but you are still feeding in the data into the system, which is much more structured. And then finally, reinforcement learning is something where data doesn't exist, right? So classic example is autonomous cars. When you have to teach the car how to drive, once you build the model, you actually send these test cars out there into the real world, and then you capture what's happening, and then the machine tries to learn when a person walks in front of it, or when a cat walks in front of it. So you can't create that environment in a synthetic form, but when you send it out, you're basically building the model and the machine learning model to learn from the realistic information, right? So again, there are all different types of techniques. We are leveraging supervised learning and unsupervised learning to basically build our system to help uncover those insights. Now, obviously, comes generative AI. So, where is generative AI in all of this mix, right? So, generative AI is nothing but yet another evolution or aspect of deep learning. And what happened is when ChatGPT unveiled its technology, what they're doing is they have taken lots of internet data, and they have used a machine learning model to train on it, and after you have trained that model, it has given it the capability to predict or produce a new content, right? The simplest one is ChatGPT, where when you ask a question, it actually generates an answer, right? So there's no answer written in any form on the internet, but it basically creates that answer, and hence it's called generative AI. It uses deep learning in the background. It uses supervised learning, unsupervised learning, and then go through the whole training process to create that model. That model is specific to that data. So if you say, "Oh, I want to use the same ChatGPT system on my own company's data," it's not possible, because that model is only understands that data set, right? So the only option you have is either you build your own training mechanism and then build that model, or you use something like retrieval augmented generation, which I will talk about in a few minutes. Okay. And then what is large language model, right? So large language model is nothing but it's basically the output of what you have trained that AI system to. So ChatGPT, if you take a look at it, what it did is it took all their books and articles and websites, all Wikipedia articles that are available on the internet, and they trained on it, spent millions and millions of dollars on it. It requires a lot of CPU, memory, GPUs, and things like that. And then once it has trained on it, it basically is able to do certain tasks, right? So text generation is one classic example. So when you're asking a question, it generates a text and gives you the answer. It can classify information. It can do, like, for example, language translation. You give English and then it understands how to translate into to answer. So all of these are generative AI technologies, and what they're doing is generating a new type of content, and hence they're called generative AI. And obviously, the companies like ChatGPT, Gemini, Llama 2, these are all large language models that are being created by these companies, and they are hoping we can leverage these large language models to help and accelerate talking to advanced systems or applications and things. Okay. Today we are working with Microsoft and Azure OpenAI, and we are integrating that into our platform. Very soon we'll also start integrating with Bedrock and some of the other technologies that are also available out there in the market. Okay. So I think, given now you have some context of where and what the AI is, I think what I want to do is now connect the dot as to how can you use these technologies internally. So one option was you can build your own model, or you can train your own model, and but can you take these systems that are already built out there and bring it into your environment, right? The answer is not quite, right? And you have to do certain things before you can start leveraging the power of these AI systems out there. Now, none of these systems are perfect. I think I'll talk about some of those capabilities in few minutes. The first thing is most of these models are not up to date, right? For example, if you look at ChatGPT, they were trained on 2022 data, and then I think the recent one is 2023's data. So whenever you're asking a question, it actually gives you whatever the information it was fed, right? So as I mentioned, it is trained on the data set that you gave it, right? So if you ChatGPT 3.5 or 4.0 doesn't understand anything beyond April 2023, right? So technically, you can leverage ChatGPT, but it's now has old data, right? So first problem we have to solve is how do you use these new AI models to understand the latest information, right? Second is hallucinations. Hallucinations is all about making up answers. I think this is the most critical part of any AI system, is how do you make sure that the answers it's creating is accurate, or at least not completely made up, right? We took the example of hey, what is Kohesti Gaia? And as you can see here, it actually did not know the answer, and so it starts making up the answer. And so they are inconsistent, irrelevant, and inaccurate, right? So you can't just take any generative LLM model out and just put it on your data. You have to work with that. You have to train that LLM, or you have to make sure that LLM understands the latest information so that it can provide those answers. And then finally, it also doesn't understand where the genuine source of information is, right? So most of the LLMs or large language models today are trained on some public internet data. Nobody has sat there and realized, okay, which articles are actually the right articles versus inaccurate articles, right? So it has become very biased in answering those questions because it's based on what it learned on the internet, right? So the source information also becomes very important when you are trying to use these technologies in your environment. So I think the best way to understand what RAG is. So RAG is a new term that I think, or a technology that is coming up, and it's all about retrieval, information retrieval, by using the LLMs without needing to train those LLMs. And I think I'll use a very simple example to kind of connect these two together, right? So you have this large language model which understands English or other languages, but it does not accurate. It's not up to date, right? So it's a very simple analogy would be like if I wanted to ask the LLM, hey, which planet has the most moons? The answer would be Jupiter, which is 88 moons. But in reality, the answer is actually incorrect, and the reason for that is because if it knew that NASA has actually the latest information on all the planets, the right answer is Saturn, which has 146 moons, the system wouldn't have hallucinated or made up the answers, right? So the key here is like how can we make LLMs smarter, or how can we make them up to date, or how can we make them only leverage reputable source of information so that the hallucinations are not present. And so you solve that problem by using a technology called retrieval augmented generation. And it's in short form, what it's doing is it's retrieving the right information and then augmenting the LLM so that it can generate the right answer, right? And the right hand side, I've drawn a very simplistic picture, right? Before you give the answer or a question to the LLM, what you are doing is you are adding an extra step of information retrieval, and that information retrieval is coming from a reputable source. And here the reputable source could be, let's say in this example, it would be, hey, let's look up NASA's pages before we get the answer. Or in other words, it could be your information. So imagine if you were to use the LM, but there was a way by which you can say, hey, these are all my corporate documents. So before you answer the question and look and give me some random answers from the internet, what if I'll give you the information from my data in my company, and then you then use that context or that content to answer that questions. So now certainly what you can do is you can use the power of your content and the LLM, combine it all together using what we refer to as a retrieval augmented generation pipeline, uh, which then kind of connects both of them to give you the answers that are very domain specific, that are very up to date, and obviously with minimal hallucinations, right? So at the end of the day, right, what is the retrieval augmented generation doing, right? So it's number one, it's costless, right? Because you didn't have to go and train another LLM, right? You actually can leverage off-the-shelf LLMs. You could use Azure OpenAI, you can use Bedrock, right? All of these LLMs are becoming very, very sophisticated, and they are spending all the millions of dollars that you don't have to do. Second, you get answers that are very up to date and relevant to the content that you provided to the LLM. It's more accurate because what you're doing is in drag right now you go through all those thousands of documents, and then you find the relevant information to answer it, right? When I was asking how many moons are in the Jupiter, what we will have to do is you will have to look okay, all the research papers, and then find the papers that talk about all the number of moons that are present in those planets, and then only refer that to build the answer. It reduces hallucinations because you are only retrieving the information that is relevant to the question, rather than any random data that is available on the internet. No training required, and because again you're not spending your time and money to build a new LLM, right? and and yes, I think it also helps you acknowledge when we don't find relevant data, we don't just make up the answers. You actually now have the ability to say that didn't find anything that can answer the question, so maybe there's more research required, or maybe you can feed me additional documents to answer those questions. Okay. All right. So I think if I put it all together, right? So we talked about AI. AI is the obviously the biggest umbrella, and then we have machine learning, which is ultimately an area where you teach the system how to predict, or how to generate a content, or how to perform a task, right? And then we have deep learning, which is basically another way of learning the systems, right? And then you have generative AI, which is a specific field within deep learning, which is completely focused on generating new content, right? And then you have a large language model, which is ultimately designed to understand languages, and then predict how to generate answers in that specific language, right? So if you take GPT, or if you take some of the new large language models, they all understand spoken languages, and they can convert and understand and predict answers in those spoken languages, right? And then what we are doing here is we are leveraging the large language models, we are leveraging the neural networks and generative AI all together to build a solution where you can actually have a very similar an experience like ChatGPT, but it is completely made for your environment, right? So you could be a semiconductor company, but you can ask it questions upon your corpus, and it actually answers only based on that, or it could be a hospital or a bank, right? So we have taken the LLM, we've taken your data, and we've kind of created a drag, like a glue, so that you can actually deploy a system which is very specific to your environment. Okay. All right. So let's talk about, I think, Kohesti guy a little bit, touch on that, right? So um, what we do is we help companies secure their data, manage their data in a very high scale, and so we have a whole platform and a suite of products that basically can talk to your systems and then create a backup or a protected copy of that. We secure it. We have different portfolio of products that help you look for ransomware, look for inside, look for various different threats that may be lingering on your data, and then secure it and lock it down. And what I'm talking about today is all about insights, right? So as we collect all of this information, we are some way becoming what a lot of our customers call as accidental data lake. And what's happening is all the different systems are bringing all the data and storing it on our platform. But what if we had a little flashlight where we can start pointing it at various different data sets and then start asking questions or start getting insights from that data. One of the beauty that we have is that we can store data for a long period of time because we are a data protection platform. You can actually go back in history. We have customers who are using it for compliance or for auditing or for legal discoveries, where they can actually see and shine that torch all the way back to years worth of data, as opposed to what you would do on a primary system, right? So that's what I'm going to talk about a little bit in the next few slides. Now, obviously, as you can see here, the traditional systems have been very focused on, hey, I'm just going to create a backup and I create a copy of the data and secure it. But since you have all of this information, there was no way to get these insights in. A lot of times you had to actually restore it, or you have to take the copy information out of these platforms, and it basically made it extremely hard to search and analyze, right? And we are taking a completely fresh look where we are saying that, hey, if the system, if this platform already has all of this information, why not give them a very simple chat GPT like interface, right? Imagine you could just go into your system and start asking questions, and if you clicks, you can actually start getting those answers, right? You don't have to move any data. You basically are bringing those LLMs or these new AI technologies into your environment, into your company, rather than taking the data out and sending it outside. Okay. um, I think as I mentioned, right, the game is all about information retrieval, right? So most of these systems, before they can answer the question, right, they need to get the relevant information, right? If I wanted to know about how many moons are there, I shouldn't be looking at any other data other than just papers that are written on number of moons on planets, right? I don't need to look into the black holes and other things. I just need to focus on that, right? So traditionally today, what happens is your data is spread all over the place. So if you had to find that information, or your end user has to find that information, they have to go multiple places. And, another example I use is, imagine you had 10 years worth of data in your filing cabinet, right? If you ask somebody like, hey, can you find this, let's say, paper which was talking about this information, right? Unless you had a very good catalog or a good indexing system, somebody has to actually go through all of those files to find out what they are. Second, most of the systems are keyword-based search, right? Which means what you're asking actually does not exactly translate to what you're searching for, right? So a simple example here is, if I said, hey, go and find all the files that is talking about the pets, right? Um, so until unless your documents have the word pets in it, there is no way you can actually search the information. You will have to specify cats, dogs, horses, because that's how these current systems are, right? They look for specific words and they only search for them. With the new AI technologies, you understand the intent and you understand what actually it means, and then go and search for that information, right? And then finally, you have to go and manually retrieve all those documents, and then read through the documents to analyze and bring up an answer, right? With the Gaia, what we're trying to do is So number one, we've using our platform, customers bring all the data in one place. So we solve that by using our platform. And then what we've done is we've built a semantic or an intent-based search. So when you ask a question, we first go and look for that information based on the semantic similarity or various other algorithms that understand the meaning and the similarness of that content. And once we have done that information retrieval, we use a RAG pipeline to actually create the answer that is very relevant to the question that was asked, right? So you go from a very manual and a slow mechanism of finding information to a fast and a very relevant like the methodology, which can actually save a lot of time for a lot of your teams and employees who are on a daily basis spending hours and days in finding information. Okay. All right. Um, so um, so at Cohesity, we have various different products. As I mentioned, we have a data protection suite, which helps companies protect their data against all sorts of disasters, anomalies, and threats. We have the data security suite, which is all about protecting it and detecting and analyzing threats. We have mobility and data access suites, which are all about moving the data and making the data available at any given point in time. And with Cohesity AI, we actually just started, creating that flashlight, as I mentioned, to help customers, go and interact with the system and then get answers to the questions that they may be looking for. Um, we have been using AI for a very long period of time. We have all different technologies. I won't go into any of those. They're all spread over in all our technologies and the suite products. But obviously, what we are talking today is about Cohesity Gaia, which is that little flashlight or a chat GPT like technology that you can run to get insights on your own data. Um, it's very simple. We try to keep it such that any non-technical person can use it. We borrow a lot of concepts from ChatGPT and Microsoft Copilot. So if you can see the interface, it's as simple as having a chat bot at the chat inputs at the bottom, and then it asks questions and it answers questions, right? So it's just like how you would do it in your text message or on a Copilot like technologies, but imagine that it can actually look through thousands and millions of documents across your enterprise. So it has a very simple interface. We have a scalable search, so we can search through large files simultaneously. We use generative AI technology, so when you ask a question, we actually generate an answer which is relevant to the question that you asked. And then finally, we can open up most of the common formats like PDFs, Word documents, PowerPoints, text files, RTFs, and PDFs, and things like that. Okay? So imagine a system which can, you put all your unstructured data, and then have a little Q&A like technology in front of it. Okay. So in short, I think Cohesity Gaia is all about it's a very simple AI-powered conversational assistant that helps you have a human-like conversation with your secondary data, right? Which obviously we capture on our platform using various different connectors. So you can literally type in an English language and then get the answers back in an English language. Obviously, you have to have your data on our data cloud so that we can go through and provide you their answers. Now, a little bit extended definition. I think if you connect all the AI pieces together, what we're doing is we take all the data that comes on our platform, we index it. We index it using the RAG pipeline that I just explained. We take all the files and then go through that, and then connect the dots by leveraging an LLM. Right? We didn't write an LLM. We believe that I think Microsoft and OpenAI and Amazon are have enough horsepower and money power to build the best LLMs. So we basically leverage those LLMs. In future, we will actually also allow customers to bring their own LLM. So let's say you were you had built your own LLM for your very specific kind of information. So you could also plug in those LLMs so that we can then talk to the data that you have stored on our platform. If you look a little bit under the covers, what we are doing is, on the left hand side, if you can see, you have an interface where we ask questions and you get an answer. But the core engine, it does basically four things, right? The first is, obviously, you have to index the information. So you ingest into the Gaia engine those documents. We extract them. We open PDFs, Word documents, things like that. We extract text out of them. Then what we do is we create what we call as an index. So where you encode and you embed and you create these floating point numbers, which actually represent the data, right? So the data remains on the Cohesity platform, but what we do is we store those indexes, which is basically those floating point numbers, which represent that data. Then when you ask a question, what we do is we retrieve most relevant information. So when I was asking about, hey, can you tell me all summary about all the documents that are talking about pets, we will go and look which documents are actually talking about pets, which means if it was talking about cats, dogs, horses, then we would pick up those documents out of those millions of documents, and then use those documents and the text within those documents to understand the relevancy of and the relevant parts of that documents, so that we can then construct an answer for the question that you're looking for, right? So we do various different things internally: re-ranking, similarity search, cosine search, and all sorts of things like that. And then finally, when you've gotten the context, we leverage LLMs. We create the prompt, and then we use that context that we found, and then to put together a generative response, right? So once that generative response is created using the LLMs, that's what you at the end see as the answer to the question that was asked. So again, I think at the end of the day, you get the benefit of speed. We're doing all the work internally. Security, because everything is secure, stored in a secure fashion, and then extracted and managed through a secure pipeline. It can be done at scale. We're talking millions and billions of files. Extremely simple, right? So that you don't have to build all of these pipelines all together. And then finally, using a very specialized techniques, so that we can build the vector database and the embeddings and the optimizations all around it, right? So you get a full end-to-end experience of ChatGPT like experience, but on your own data rather than any internet data. Okay. I think I won't go through all of them, but the point here is that by having giving you the fully integrated experience, you can reduce time, you can reduce the number of copies you make, you can reduce hallucinations, you become very context aware. The answers are very to the point, or very domain specific, and at the end of the day, you don't have to spend millions of dollars in doing and building your model and producing an LLM, which can be very expensive. Okay. Um, and then finally, I think if you pull it all together, there are various different ways our customers are leveraging Gaia. We have customers who are looking from an e-discovery perspective, going through hundreds and thousands of legal documents. We have customers who are using it for enterprise search, where they may have some departmental data that they want to have exposed within the company. I can imagine somebody actually we have customers who was trying with Slack, right? They integrated Gaia, so they were literally asking company policy questions or research paper questions, and you're able to get those answers instantly. For support, we have customers who are trying out for internal support usage, knowledge management, basically another way of saying if I have a certain specific domain information, they can leverage it and they can consolidate it in one place, and then all their researchers or their knowledge workers can use Gaia to search through that information in a very fast manner. Report generation, content generation. So there's all different. Again, every company customer has a different way of how they want to use it. But at the end of the day, we all store data in documents. Finding the information through documents is extremely hard, right? And when you take it from to millions of documents, across 10 years, 20 years, 30 years, I think the task becomes extremely complicated, right? So that's what we are trying to solve for. So with that, I think what I'm going to do is pause here. I know I went through a lot of information here, so and see if there are questions, and I'll pass it to Nick and see if there were any questions that came up on the chat. If there are none, please feel free to add it, and I'm happy to take them right now. All right, Nick, were there any questions? Let me see.
Yes. Thank you,
Okay.
Vikram. Here's one from the
Yeah.
audience. What are the potential risks and ethical considerations associated with using generative AI for data analysis and decision making in enterprises?
So I think the first one is security. I think you have to definitely think very carefully, like how you leverage generative AI and what type of data it has access to. Where is this generative AI technology running? Is it running completely outside your control? Do you have checks and balances on which you can control what it can do? We at Cohistory and with Gaia, we have taken a lot of effort in trying to make sure that when we send any information to any large language models, it's very narrow, right? It's only specific to that question, and we have and then obviously Microsoft has given us the ability to switch off any learnings that they may want to do, right? So we actually don't allow Microsoft to use that information to learn anything from it, right? So I think you have to be very careful in terms of how you are sending the information, and then how it's being exposed to the generative AI technologies. I think from the ethical side, I think obviously there's lots of responsible AI pieces that we can talk about. Probably a lot longer conversation, but I think you have to have a responsible AI framework in which you articulate how the information again will be shared, exposed, and then consumed right at the end of the day. None of these AI systems are going to be perfect anytime soon. Um, so I think what we generally say is these are not your expert systems; these are assistants, right? So your people are still the key people who are most knowledgeable and experts in any subject. Use these technologies to assist them rather than replace them, right? Because they are still very, very early, and they're not perfect in any shape or form. Hopefully that answers your question. But if you want to have further conversations, we can have a separate meeting for that. Okay. Any others that came up,
Yeah,
Nick?
yeah. Here's another one. What are the best practices for integrating Gen AI solutions into existing business workflows to ensure minimal disruption and maximum benefit?
So I think we fundamentally believe. Um, I think you should try uh, for any generative AI or any AI system, right? Data is the most important piece. Your AI system is only going to be as good as your data that you have trained it on, or the data it has access to. So I think some of the best practices I would say is make sure and you have a way by which you can either consolidate or bring your information in a central uh, framework such that these AI systems can access. Because if you had data spread over multiple silos, and if you didn't have a way to connect all of them together, your AI system will only be as good as that silo of information that you have given them. So I think that's one. Number two, I think, is security. As I always mention, I think security is the number one thing that I think we believe that um, um, is very important and critical, because these systems are very advanced in if you look at from that perspective, they can learn from it, they can understand. But who have as you give access to these systems, make sure you understand So security ramifications mean people should not have access to it if for the data that they didn't have, right? So there's a lot of work that has to be done on that piece. And then finally, I think the responsible AI piece, making sure that you have lots of checks and balances and guardrails to make sure that it doesn't get utilized in the wrong way, right?
Great. Here's another one. How
Sure.
secure are the LLMs used? Will it work with private LLMs?
Yes. So today, obviously, so what we have done is we've built it as a, if the question is specific to Cohesity Gaia, we have built it in such a way that, like I think as I was showing you in this diagram, we want to leverage the LLMs as an API. So today we are using Azure. Very soon we'll use Bedrock and Gemini. But we fundamentally believe that these language models are what I think we all call it as foundation models, right? They are generic, they understand certain things and they can give you and they're capable of doing certain things. But very soon, every enterprise will start looking into like, hey, I want to bring my own LLM or build my own LLM because some of these LLMs, rather than using a foundation or a generic model, they can be trained or they're specific to your environment. So I'll give you an example. We had a customer who builds chemical bonds for paints and plastics and things like that, right? They can't use a generic LLM, right? So they are thinking of like, hey, maybe I can create an LLM which understands the language of chemical bonds, right? So the standard language models understand English and spoken languages, but that's one way of building an LLM. The future of LLMs could be, hey, I have a LLM that understands chemical bonds, or there's another LLM that understands a different language, right? So think of them as different LLMs, and if you decide that you want to build your own LLM, which you can, then what you can do is you can plug in that LLM into Cohesity Gaia, and then leverage the data that you have within the company, and then use the RAG to connect all of that together.
Great. Here's another question. What are some examples of real world challenges that Cohesity Gaia helps address?
So I think the simplest one is information retrieval or information search, right? I think um, um, all of us, or all our teammates and employees, struggle and spend hours and hours in finding the information, right? The only option we have today is Google or things like within Microsoft, documents or a Finder on your Mac, right? There's no corporate level information retrieval system, right? So what we are trying to do is help customers bring all of that information, put a simple interface in front of it, and help our customers save time, right? And at the end, when you save time, they become extremely productive. And when they become productive, you get to get the benefit of it, right? So we are trying to right now first tackle the problem of information retrieval and generating the answers on unstructured data, right? There's a lot of tools and technologies out there for structured data, and structured data by definition, has a meaning and a structure to it. Unstructured data is like PDFs. I have a customer who has 10,000 PDFs, and their people are spending months and days to just get basic information out of those, right? And when they get it, it's like so many hours spent. So we think that I think the LLMs of today and the data that you have, I think, have reached a certain maturity where I think we can disrupt search in some fashion. And we don't want to build another Google, right? What we're trying to do is help customers do it on their own specific data, right? Nobody wants to take the data and send it to the cloud and then give it to those and expose their intellectual property. What we are trying to do is keep the data, bring the compute or bring the intelligence of these AI to your data rather than moving the data to them, right? And so that helps them secure it, contain it, and put their arms around it, and have full visibility on it.
Great. And I guess the second part to that question is my backup data being modified as part of this process?
No, right? Backup data is, I mean, as I said, right, it's your data protection, right? It's your secure copy. We never modify any of this data. Well, as you saw in this picture, the data remains in this left bottom box. The cloud in the Cohesity Data Cloud, the data is always, um, never changed, right? So it's always written to. It's always like whenever we write any new information, it's you always create a new snapshot. So data is always cast in stone, right? As the new data comes in, they're always written as increments. So and that's why you're able to go and see all the way back into the history, what changed, what is new, what is old, and things like that.
Great. Well, thank you again, Vikram, for such an incredible thought leadership. And I want to thank everyone else for joining us today. This session, along with all of today's content, it'll be available on demand following the event. As a reminder, please be sure to check out the prizes and raffle rules section to see how you can earn points for the chance to win a prize. Our next session will begin at 2 p.m. Eastern Time, which will be a panel discussion titled Talent on Tap: AI Workforce Optimization. Please click on the join button that will appear on your screen to be redirected to the next session, and we look forward to seeing you there.